Hello everyone. In this video, we will understand about how do we determine sample size while estimating population mean or while estimating population proportion. First question. The placement office of a leading management institution is planning a survey of annual earning of its MBA alumni numbering 3,000. How large a sample size it should take in order to estimate the mean annual earning within plus or minus rupees 1,000 and at 95% confidence level. The standard deviation of annual earning of the population is known to be rupees 3,000. So we will solve this in the next slide. So since it is in order to estimate the mean, so here if you look into, it is actually talking about mean annual, means population mean is trying to get estimated. So the formula for that will be N is equal to Z sigma divided by E, the whole square, where our N is the sample size, Z is the standard normal test statistic value for the given confidence value, the given confidence level. And then your sigma is population standard deviation. E is the tolerance error, how much error is acceptable. So here, further, for a 95%, here in this question, they said 95% confidence level. Z will be 1.96. So N will be now Z, which is 1.96 multiplied by standard deviation. Population standard deviation is given in this question as 3,000. So multiplied by 3,000 divided by error tolerance is given as plus or minus 1,000. So it is plus or minus 1,000. So when I square plus or minus, whether it is minus or plus, it will become positive only. So we can simply consider it as 1,000, which means straight away it is 1.96 multiplied by 3, it will become simply 3. So when we do that, we will get it is 3 into 1.96. Whatever result we get, we will be squaring that, which means we get 34.57, which is round out off to 35. That will be the sample size required. Let us move on to the next question. Suppose the population proportion is estimated as 60%, which means our p-value is given as 0.6, which means our q will be 1 minus of p, that will be 1 minus of 0.6, you get 0.4. And the confidence is set as 95%. Already we saw for a confidence level of 95%, Z value will be 1.96. Allowable error is given as not greater than 2%, means maximum it is 2%, which means it is 0.02. We are supposed to calculate the N value. So N will be, we will have Z square times P into Q divided by E square. That will be now, Z square is 1.96, the square, P is 0.6, and then Q is 0.4 divided by 0.02, the square. So let us calculate that. 1.96 the square into 0.6 into 0.4 divided by 0.02, again divided by 0.02, because there is a square there. We get 2304.96 rounded off to 2305. That will be the desired sample size. Let us move on to the next question. A manager of a departmental store would like to study women's spending per year on cosmetics. He is interested in knowing the population proportion of women who purchase their cosmetics primarily from his store. If he wants to have a 90% confidence of estimating the true proportion, this is also a problem related to population proportion. But here the p-value and q-value are not being given. So we'll consider both of them as 50%, means p is also 0.5 and that will be the same as q. We are going to consider that, which means our n value will be z square, again divided by divided by p into q into, multiplied by p into q into e square. This will be e square. And here z for a 90% confidence, for 90% confidence, z value will be 1.645. So you have here 1.645, the square multiplied by 0.5, again multiplied by 0.5, divided by e square. E is given in this question as within plus or minus 0.045. So 0.045 plus or minus the square. Means whether it is a plus or minus, when I square it, it becomes positive again in the denominator. So when we calculate this, we get 334.08, which is round up. You always, while determining sample size, you always round it up. That means it becomes 335. That is the solution for this question.